this video we're gonna consider transportation model. Let's define transportation model first. Let's see in this example. So we have a car company. They have three plants, three manufacturing plants, factories in Los Angeles, Detroit, and New Orleans, and two major distribution centers in Denver and Miami. The quarterly capacity for the three plants are 1,000, 1,500, and 1,200, and the demand of the distribution centers for the same period are 2,600 and 1,400. The mileage chart distance between the plant and the distribution center is given in the table below. So we have tables. Those are the distances between Los Angeles and Denver. Those are the distance between Los Angeles and Miami, as you could see here. The trucking company in charge of the distribution, they claim that it should charge them, it will cost 8 cents per mile per carriage. To move a car for a distance of 1 mile, to transport it, it will cost 8 cents. Okay, so first let's calculate amount of money from Los Angeles to Denver. So if we go back here, we have 1,000 miles between Los Angeles and Denver, and each car would cost 8 cents to be moved of a distance of 1 mile. So if you have 1,000 miles, so it is 8,000 cents or $80. In the same way, we calculate the other distances, how much it costs to move a car from a source to a destination. So all are the sources where the car are made, and those are the destination. So those are the values we have. Okay, so concerning this table, the one we see here, so we have we have three distribution centers. We have Los Angeles, New Orleans as distribution centers, and we have a supplier as a distribution centers are Denver and Miami. So we have three manufacturing plant, or where the car are made, or the source Los Angeles, or supplies Detroit and New Orleans, and we have the customers are in Denver and Miami. Okay, to start with, let's calculate. We have we need 2,300, 1,400 for the car. Okay, and as well as we do need, or we have supply of 1,000, 1,500, 1,200. So in total we have, or we need 1,000, 1,500, 1,200, 2,000 or 3,700. Oh God. And here we do have 3,700. So the system itself is balanced. What's meant by balanced system? The amount of supply equals the amount of demand. Okay, so the system is balanced. This method is to minimize the transportation cost. Minimize the transportation cost, it means like you have to start with the cheapest one. So as we said earlier, the system is balanced. And so let's start by solving the problem. The cheapest one we have, so in order to send a car from New Orleans to Miami, it costs like $68 for the whole trip per car. So we start with this one. Let's change the pointer color to red. So we start with this one. Then New Orleans does 1,200 cars, and Miami it needs 1,400. So we send all of them. So here is 1,200, and so we send all of them this way. So the remaining here will be 200. As you could see here, the remaining is 200. We send all of them on this road, and so the next one will be 1,200 for this. The next cheapest road will be 80. Los Angeles does 1,000, and Denver it needs 2,300. So we send 1,000 on this road, and here there's no need anymore, so we cut this, and the remaining here will be 1,300. Okay, so the next city will be 100. So we start by considering the cheapest cost to transfer a car from source to destination, and then the next one and the next one. So it will be here 1,300, and here will be the remaining, like here 1,200, and the remaining here is 200. Okay, so what you got here, like so all explained. So we decided at the end to send 1,200 from New Orleans to Miami, paying $68. Okay, which is the one here. Okay, so point option arrows, so one here, so 1,200 times 68, and we send like from 1,000 from Los Angeles to Denver. So we multiply those numbers, 1,000 times 80, 1,300 times 100, 1,200 times 68. Each car costs 68, so we decide to send 1,000, so multiply them. 200 times 108, total 313,200. Okay, so this is the balance system. I remind you, the balance system is like the amount of cars in this example available at the source equals the amount of car needed at the destination.